Question 9 is another histogram question, but arguably a little more demanding. The incomplete frequency table and histogram give some information about the heights in centimetres of some tomato plants. And I know I'm given 3 frequencies. I'm given 3 bars, but they don't correspond. And I'm asked to use the information in the histogram to complete the table, and then use the information in the table to complete the histogram. So the first thing I need to do is work out the scale on my y-axis. So between 10 and 25, that's not useful to me because I don't have a bar. Between 30 and 50, again, not useful, I don't have a bar. But between 50 and 60, I know this area must be 20. So that means if this is 10, and the area must be 20 units squared, then this must be 2. So I can label 2 on my y-axis. And because my scale must be linear in a histogram, I can therefore label 1, 2, 3, 4. And they will always choose values that are pretty nice for doing this. So I can now then use this information to complete the table, because I know the area of each bar is the frequency, like in the previous question. So from 0 to 10, I have 0.5 on this axis, I'm halfway up to 1, times 10 is 5 in total. And then between 25 and 30, I'm going up to 3 here, so I have 3 times 5, which is 15 as my frequency. Then use the information in the table to complete the histogram. Between 10 and 25, I have a frequency of 30, and my interval is 15. So using frequency density is equal to frequency divided by class width, in this case I have my frequency, which is 30, over my width, which is 15, so my frequency density is equal to 2. I then do exactly the same thing for 30 to 50. Here I have my frequency for 30 to 50 is 50, and my width is 20, so 50 over 20, 5 over 2 is 2.5, and so I can draw my bar on as such, and that's another question finished.